5%.
Really?
Yeah, it's really...
Wait,
Actually,
now it's kind of okay. Maybe it's because I need to get used to it.
no, that's the thing. So we want to pay attention to our voice. We just want the music to be listenable when we are all in silence. So because of that requirement, I'm putting like... Actually, I am with 1%, I think.
Okay, like the string already started. Can you
Okay, so
try?
now I will mute you and the bot, so then I can have a thing. I need you to speak, Nathan.
Speaking now, loud but silent.
No, your audio is really like on par with the music, man.
What that means?
My audio is fine though.
No. Like, what does that
It
mean?
means
Like,
that your audio is too slow. Too low, sorry.
uh, oh, okay. Okay, I'm trying again. Trying to
Okay,
speak
say
like
again.
not too loudly, not too silent, but usually I'm louder when we are like stream. Like I'm eventually almost screaming. So it will be
No,
louder
okay, it's
than
fine.
this usually. Is it? Is it?
Yeah, it's fine. I will close now and
Okay.
unmute you.
Okay.
So unmuting. Okay, I think we're fine.
Okay. Just one thing. Are you like set up to like stream stuff? Like, have you closed it? Stuff that.
Yeah, I
Okay.
am.
So okay, I'm watching on Discord, and I will also open VS Code if I need to modify some.
Yeah, no, you can. I think you already have, because you have an account. You can enter the thing, the session with no invites.
Oh.
Okay, so what we're gonna
Oh.
do today?
Oh. Okay. I was searching a project, man. Like, but I forgot. I don't have it. I will just open VS Code.
No, you can have it. You can like
No,
pull
no,
the
no, no.
repo.
I'm not saying I cannot. I'm saying I haven't. I don't
Oh,
have
okay.
yet.
Okay,
So,
that's fine.
CD programming projects. Open that.
I would also say to you to send on the announcements channel.
Oh, okay. Just a sec.
I'm planning on adding a webhook for that because you're gonna forgot. I can already tell
Oh,
you.
like starting the
Yeah,
stream. Oh.
yeah.
I wonder why. What's the name? White Soden doesn't do that. Like, right? Like he always. But let me see.
You can add a lot of webhooks, man. You can add webhook for Twitter, for Discord, bunch of different things.
Oh, okay. We need to investigate that later. But I can invite you, but I'm not sure about joining your session.
Okay, so let me invite you because I think I can. Yeah, I have here you
Oh,
here.
okay. Directly, right?
Yeah. So let me. Oh, I need to start the session first. Okay,
Oh,
makes
okay.
sense.
Oh, wait.
Okay, so it's not automatic.
Join collaboration session. Operation cancel. Oh, okay.
Okay, so I think you should be able to join now.
Strangely, I can see here like join collaboration session.
Okay, so just
Oh
go.
no. He's asking for a URL.
Okay, so yeah, you need the URL unfortunately. So here it is in the Huffman chat. Oh, I love the song.
Poster. Man, I cannot really identify like songs of enemies. Like, uh, yeah, I usually can't.
Yeah, this is Unlasting. It's an enemy for Sword Art Online.
Is it
I love this
what?
song.
Unlasting is the name of
Unlasting.
is the
Yeah,
name
the
of
song.
song? Okay.
The song.
Let me see Discord. What is the channel that I have to? Is it general announcements or?
Yeah, announcements in general.
Okay.
Yeah, 10 minutes late, but I think it's fine.
Yeah, like people don't really mind.
I really hope that the audio is okay though. Don't
Yeah.
you want to check?
Let me try it, but let me
I
see.
think you can just mute me and the bot and
Okay.
open the stream
Okay.
because we can't edit this after the fact yet. In the
Yeah.
future, maybe we will be able to.
Uh, try to keep talking.
Okay, I will try to keep talking now. Okay, so I will talk about what you're gonna be to take care of.
Wait. I just noticed we are kind of dumb, man, because
Okay, no, that's a possibility. I,
Uh,
I agree.
no, see. If you are muted and I'm not listening to you, I'm not streaming your audio, so I cannot check anything.
Oh, dumb.
Man, you are the only one that can check this.
Okay, so
Like,
I'm the only one that take. Okay, all the
I
responsibility
just
on my
noticed we
side,
are.
basically.
No, but like if you watch the stream and you say, oh, it's okay, the audio with Nathan's voice, if the
But you're
like
trusting me.
yeah, but that's the thing. You only need to check one case. Is the music too loud? If it is too loud, that's a problem. If it's too low, that's not really a problem, right?
Okay, so it's fine. Yeah,
Uh,
it's definitely fine.
okay.
We can go.
Okay, I have everything prepared.
Hello.
Okay.
Okay, now let's start this party here.
Do you
Okay, so
remember?
like I was saying,
Do you remember in which part we were? We were.
yeah, I remember. Yes,
Okay.
if you go to the Huffman Wikipedia page, no, not with the Huffman. If you enter this file here that I sent in, this file here on my Python implementation. Last session, we ended discovering that the Huffman code function and the translate symbols function, they are kind of complementary to each other.
Wait. I cannot see you. Are you showing?
I just sent you the link on Discord.
Oh, okay. I see.
Okay, so if you go to this file right here, so this is the encoding part. So we have the Huffman code function and the translate symbols function. We discovered last session that these functions are kind of complementary to each other.
Wait, man. I think it's better either for me to take a look at sharing it to you, or even better if you share it there on Discord. That way
Okay,
we are sure
okay,
to be seeing the same thing.
okay. So I am sharing in the live now.
Okay.
Okay, so we discovered last session that this function right here and this other function right here, they are kind of complementary to each other. And we discovered that these two functions are traversing the tree in two different ways. So this dictionary right here, it's kind of acting as the tree, although it's not a tree, as an abstraction, right? Probably the implementation is a tree, but in terms of like how we see it, it's not a tree. So this symbol dict is creating this tree here from top to bottom, right? So bottom up strategy of creating the tree. And then this function right here, translate symbols, is picking this already made up tree and traversing top down, right? So it's picking this and then converting, like translating the intermediary symbols to the symbols that we actually want. That would be the ones and zeros. It's not getting rid of the intermediary ones because then we are filtering that later. But what we are doing here is basically doing a two round pass on the tree. And that's exactly what you're going to be trying to mimic today, as far as I can tell. So the first function is a function that picks the lowest and the second lowest symbols in terms of probability. So that would be like the C and the B here. And then we are combining them and summing the probabilities up. And then we are already establishing the future bit representation. So for instance, we have the one symbol would have CB plus 1, and the other one will have CB plus 0. And then we are saving that on our dictionary. And we are adding the new symbol because the new symbol is going to be CB, right? You're going to have to do the same we're gonna treat CB as exactly as we're treating C and B separately.
Okay.
But we're gonna compare with E, and then we're gonna do the so on and so forth until we have
Yeah, the,
passed.
the step 3, right?
Yeah, exactly. So this is how we're gonna do it, and yeah, so that's the first function, and we already started. Okay, so now we're gonna go back to the code. So if you open Visual Studio Code, you will see
Oh,
that we
okay.
have we have two functions. Um, we have one function. Sorry, we have one function is called create Huffman tree. Are you here?
Yes.
And this function, for some unknown reason, we call it accumulate hash map. Actually, makes sense, right? Because we're gonna mutate a hash map. So we have the binary tree, because this is a representation of the symbols themselves, right? So they are composed, each node, just to everybody to be on the same page, each node is composed of a probability and a symbol, right? So we have these two here. What you're going to be doing is we're going to be picking the lowest and the second lowest heap nodes in terms of probabilities. And I also remember this is actually crucial. In the last session, we changed the implementation of this guy to a mean heap instead of a heap itself using the reverse trick. That, yeah, this is a Huffman particularity, but
Ah,
because we want to have the lowest, right? So previously, without doing the reverse, if you pop the heap, the binary heap tree, you're gonna have the greatest and the second greatest probabilities. We want the opposite of that. So we changed the rule here. We changed the method. I don't know how you're gonna call it, the methodology. So then when we pop the first, we're going to have actually the lowest, and the second pop, the second lowest. And then we can actually create the new node, which is a sum of the probabilities of both of them. And we are concatenating the symbols, right? So we are doing string concatenation. And then now what we need to do, right, is to actually put mute onto this, something like that, because you're going to mutate this hash map, as far as I can tell.
okay.
I don't remember the syntax for this though.
Let me see. I guess it's a reference. Yeah, I guess
Yeah,
yes.
yeah. So now we're going to mutate this hash map because you want to do exactly as we are doing on the Python implementation. If you go back to my screen, you're going to see that when you concatenate the new symbol, we are pushing this symbol to our. Oh, that's actually important. We are actually adding this new symbol to our heap of probabilities, and then you may ask why. The reason why we need to push this into probabilities is because then this new symbol with 8 will be compared to all the other probabilities of all the other symbols. So we need this new symbol to also be added into our tree, to our tree of probabilities and symbols, right? So here we are pushing it, which means that the binary heap also needs to be mutable, like this. And then we are saving, right? We are saving the lowest with the symbol, the new symbol CB plus the bit 1, and then the same thing to the left, but with the bit 0. And then we are finally saving to the dictionary the new symbol. So this is what we want to do here.
Okay. But let me try to see if I know what we want to do in Rust. So you have the heap, and basically you will like pop out of this the two lowest ones, right?
Yes.
And based on that, you can already like okay, you can already like start to say what will be like the byte representation, right?
Yeah, the bit
So
representation.
okay, the bit representation. So you can already start to putting that on the hash map and like
Yes.
go updating that as long as we know more about the representation.
No, that's the catch. We are not updating that at this stage. This Huffman code is not updating any created symbols. So, for instance, we're not gonna ever update during this Huffman code function. We're gonna never update CB with B is always going to be CB plus 1.
Wait, no. I'm talking about C7. Like, take a look on
Yes.
7 on the left. You have
Yeah.
there like a map, right? From char to bit representation. So what I mean is, each step of this thing, we have like, oh, okay, this char, and we know a little bit more about it of the bit representation. So we will be mutating the hash and updating that, right?
No, you're talking about this 7?
No, I'm talking about 7 there, the step 7, and on the left.
Oh, okay, yeah. Okay, so in order to get the step 7, we need to do these two functions one after the other. So the Huffman code, it will create this tree, but it's going to be kind of incomplete. You may ask why, because you can see that B is 1 1 1 1. But
Oh, okay, you want to do in 2 passes, right?
yeah, one
Oh,
pass we create like a imaginary representation with kind of way, because we're going to have B is what? B is whatever is CB plus 1. This is what the Huffman code function does. It creates this kind of intermediary representation of B. Instead of being the bits, will be CB plus 1. It doesn't know what CB is yet, right? It will never will, because it will never update this intermediary representation. The function that picks this intermediary representation and translates the bit representation is a translate symbols function, right? So it's two passes. One pass, intermediary representation, bottom up. And the second pass is top down, picking this intermediary representation and transforming to step 7.
okay, but let me see something. Okay. So we have the first one, like if you take a look on step 2, we have
Yeah.
like this on the left. That would be like our initial binary heap, and we choose that because it's just easier to get like the first lowest ones, right?
The
With a
first two,
min heap, if
the
I'm
two
not
lowest ones. Yes.
okay, if with the min heap, if I'm not mistaken. And
Yes.
we want to end up with the step 7 on the left. That would be in Rust or hash map, but we are
Yes.
not doing this yet. We first will do a pass on the binary heap to generate a tree, the Huffman tree, and
Yes.
then we generate the mapping, right?
Yeah, exactly. Because right now, at this point in time in the algorithm, our binary heap, which is this tree, it only has these symbols right here on the left of step
Wait,
2.
is that really right? You say that the binary heap that we are receiving is the tree, but it is
No,
not.
wait. Calm down. I'm gonna explain how that makes sense. So at this point in time, right? At this point in time, our binary heap, mean heap, right? It only has CBE underscore DA. How are we
Okay.
gonna go this arrow? This arrow right here, right? Is this push right here?
Okay, but I want to know in Rust, are you mutating that binary heap or are you
Yeah,
making
we are
another tree?
mutating. If you go to the code, I already added the mute, the like mute to the binary heap, because I'm going to be mutating the binary heap and the hash map.
Okay, just one thing. Can you show me the Wikipedia page?
Okay.
Okay, can you assure that they will follow this structure in the
They will.
min heap?
They will. Okay, so if you go to the code, I don't know, alt tabbing side by side. If you go to the code, okay.
Oh.
So if you, I want you to see the image as well. So the
Wait,
image
I
and the code.
cannot for some reason put. Oh, okay. Now I can. Okay, now I can.
Okay, so if you take a look at the code on line 38, lowest,
Mm-hmm.
this is picking the C. Okay,
Okay.
we are going to our and how are we doing this? Because every time you pop the probabilities binary heap, because it's a mean heap, we're gonna pop the C, and then the second lowest is the B, right, in line 39, and then on line 41 we are making CB. But as you can see on step 3, CB needs to go back onto the left side. You see?
Yeah, I see.
We are doing that as a
Yeah,
push.
okay. But that, okay, I understood all that, but that's the part that I want to know. When do we insert that into the binary heap? Will that be with this? Oh, wait.
when you insert in the binary heap the CB, the data structure will fix the balance for us. So it's assuring the data structure is assuring for us that if you ever do a pop again, but before you did a push with CB, I can assure you that I will consider CB on the
Uh,
comparison and find the lowest of the lowest.
wait, Lemus. How can I explain this? Like, I can see that if you go like on step 2 and if you make CB and you
Okay.
insert that on the binary heap, I know that on the step 3 it will be between the two lowest. What
Yes.
I'm not understanding or I'm not sure if that's the
Right.
binary heap will look like that picture on the right. That,
Here.
yeah, shown as a
No, it
tree.
will not because we don't have the symbol ECB. We
Okay.
don't know after like we can try to draw. I don't know if it's worth it, but we could try to draw the binary heap of this and after the CB insertion.
Oh, okay. We totally don't need that tree that is like there, right?
Yeah, these three we kind of don't care. We care about this, but
Uh,
we want to mutate this to beat this at the end. So how we are doing that? We are popping and pushing. So pop the two lowest, push the new one. Pop the two lowest, push the new one. This procedure of two pops and one push is automatically making this for us. So
okay,
this is
maybe I would have to see like the implementation of the
yeah
min
yeah
heap,
yeah.
but okay, I will trust that and we let's go with the implementation.
Okay, so the next step after having the new node is to push this into the already existed probabilities. So let's try to do that. Man,
Wait a bit, like probability, we are summing those, okay.
yeah. So look at the image. See, the probability of CB is gonna be
No,
2
no,
plus 6.
okay, but let me just see, where are, what is this L and SL? Like, where are we binding this?
Oh, we are not, right?
But why is not complaining
Here.
about that?
No, this can be an LSP problem. That's okay. Let's
What
just add
the?
the so SND.
Okay, and the other thing is about the symbol. We are cloning. Oh, okay, okay. The push str is our like concatenation, right?
No. We are not put. No, the push STR is our concatenation.
Yeah.
Yeah,
Okay.
that's right.
Okay.
Okay,
Okay. That's fair.
let me increase the volume of my song here because I for some reason it's too quiet now. Okay, it's fine. Oh my god, this is the Attack on Titan one. I love this one. Okay, so second lowest symbol string. Now the next step is probabilities push new node.
Okay.
Okay, so now we are adding to our existing min heap. We are adding back this new created symbol, and the ones before are already popped out.
Yeah. Just one thing that I will change here because like LSP is complaining. Okay.
Oh yeah, change
Same
that. Change that.
case with new no.
My LSP is not complaining. Sorry.
Is not?
Yeah, mine is not.
Oh.
I don't know. Okay, so let's continue here. Let's continue here. Yeah. Okay. So next step is to mutate the hash map, right?
Mhm.
Why? Because we want to add the new symbols. We want to add the symbols with the already like intermediate representation with the bits.
Lemos, we have a problem. Yeah, a few things.
Go.
Like two. First of all, we are creating a function, right? Yeah, we are creating a function. Like here,
Yes.
let accumulate hash map. My first question is, do we need that function?
Yeah, this is the equivalent of the Huffman code function if you go onto my screen.
Okay, but that has. Uh,
It has two dependencies.
Okay.
One is the binary heap, and one is the initially empty hash map. You're gonna pass when you call this function, the initial hash map will be empty.
Lemus, but isn't
No, it's not empty. Sorry,
no
it's
no
not
no
empty.
no no. What I ask is, do we need to create this function inside here? Isn't that one the create Huffman tree?
No, but that's the thing. Paradas decided to create this function inside this create Huffman tree. I don't know if this
Wait
is
wait.
ideal for
I
your
thought
purpose.
that was because we're thinking put this inside the folder or something. Wasn't because of that?
Um, I don't know, man.
Like
Maybe we were talking about making in the fold, but I kind of want to drop that idea
okay,
right now.
and the other thing would be that this is expecting like a mutable reference.
Yeah.
So, but we are receiving this from the arguments of this function, the parameters of this function. So
Oh yeah,
this
so
would
kind of
have
it
to
makes
also
sense.
be mutable.
No, no, yeah, but I don't know. What do you think about having a function inside the create Huffman
Yeah,
whatever?
I would delete this for now, and if we need, we can just create, right?
Yeah, we can just do like this, and then later, if we ever decided to use like that, we can. Um,
Yeah, but we cannot use this syntax.
yeah, I know. Let me just adjust this to make my
But will
virtual.
it make sense to have this name, accumulate hash map?
Um, for now, yes, because I didn't I didn't have any better name when in my implementation back in the day.
Okay.
But we also need to change this guy.
Is accumulate right? Let me check.
We're gonna return after this. What exactly are we gonna be returning? We don't need it to
Oh, okay.
return anymore.
Accumulate has two C's. Okay.
Yeah. Hash map is gonna be a string to a string. Okay, we're gonna discard the probabilities after this move, which makes sense.
Uh, so then we don't need to return anything.
Oh yeah, it's because we are mutating. It's just reference, so we don't need to return that.
Okay.
So how do you say that? It's unit? I already forgot.
We just don't put anything.
Okay. Next move is to mutate the hash map. How do we do that? I don't know. So let me search that. So hash map.
Probably we can just like autocomplete into it.
I don't know if I trust my autocomplete, man. Let's try. Okay, so I have clear.
Oh yeah,
clone,
man.
entry,
You have to share. We have to share more on Discord because I cannot see your like auto completion part.
No, but you can also autocomplete there if you want.
No, yeah, but we wouldn't be seeing the same thing slash worrying about the same stuff.
Okay, so there's a function called entry. Given the given key corresponding entry in the map for in-place manipulation, gets the given key corresponding entry in the map. Oh no, so this is not for setting. This is for getting something in the map. Okay. We want to set. We want to do some sort of set.
Man, the same happens also for like the archive slash stream. Like they are not seen.
What do you mean, man?
So you are taking a look on dot entry, but that is not being shown. Like
No, that's not being shown. But you. Let's just look at the page then. Let's just look at the page. Oh, so there's dot insert. Okay, I'm looking in the Haskell Rustback example, sorry. And there's something called insert apparently. So you can try that. Okay, key and V. The key is gonna be the lowest symbol. So let's pick the lowest symbol. And this, the value, will be what the value is gonna be? It's gonna be the new node. New node. We want the symbol of this new node.
okay,
Right?
this is I think this is not sure if that's what we want. That's only for updating, I guess.
Yeah, this is for updating. This is for updating.
Oh, okay.
But this hash map will have all the symbols. This hash map here, sorry. No, this one. So yes, this one. This one will be a hash map with like A, B, C, and D and underscore. But all of them will be like empty, mapped to empty. We are updating them to have, okay, B, instead of you being empty, you're going to be CB plus 1. But unfortunately, you're gonna have to use the same trick that we did previously. You're gonna have to clone and then push it, which is really sad. We're gonna have to do something like this, I think, if I'm not mistaken. Yeah. So as you can see, we have here a map. And we are picking B. Instead of B being nothing, we are saying B. Right now, we're gonna be new node, so it's gonna be CB, right? Imagine the new node dot symbol is CB, and then we are pushing 1 into it.
Oh, okay. I was just confused because on the description it says that if the map did not has this key present, none is returned. But that is no problem. He's still inserting. He's
Okay.
just returning none because when you already have the key, then he returns the old value, right?
Yeah, but you don't want the value in this particular
Yeah,
case.
we just ignore the option.
Yeah, and then okay, so here we are just adding to our map. We are just updating our map, right?
Mhm.
We are updating with the new bit representation, which is okay. In the Python code, I did something a little bit different, right? If you take a look on my screen right now,
Okay.
instead of concatenating the string itself, I'm concatenating the byte, right? And why this matter, right? I think this is there's a point here. Imagine that we instead of CBE underscore DA, we have the number 1 as a character. You see that we're gonna have a problem between the two representations. We're gonna have 1 representing the symbol itself from our byte content, and we're gonna have the number 1 representing the bit 1. I think that's why I decided to go with the byte representation.
If you want to, we can use the byte, like literally, like use U8, but then we have to deal like with masks and stuff.
Is that hard?
I don't think so. Like push to the, how can I say? Like use U8, right? Unsigned it 8.
No, but that's the thing. It's not gonna be an U8, right? Because a U8 is gonna like. How can I explain this, Holy?
Man, you have 8 bits to work with. Oh, okay, we can have. Oh,
Yeah, imagine like DAECB. You know, this is definitely more than 8 bits.
no. That's yeah, that's not it, Lemus. It's regarding the patterns that you have like there on step 7, the left. Like you have 4 bits there to represent in the. And,
No, but the bits will be the string. These bits here that we are gonna make at the end, we're gonna represent this as a strings of ones and zeros, and then later we're gonna transform this to actually bits. We are calling it bits just for the sake of sanity here. But we're actually gonna make is a string of ones and zeros.
oh, okay. Can you repeat the part that you said that was a problem?
Okay, I can. What I think it's a problem. So we have these symbols here, and then the new node is the CB. But and then we are concatenating the CB with the bytes ones and zero, one here and 0 here, which is
That's
fine.
really strange, man. That's really strange, though.
It's not because I am actually interpreting because I think this is generating a string with the byte 1. You see, I'm transforming
No.
like
But
this.
is it strange? Like your result or your intermediate step is being like, okay, CB and then things attached to it. You see?
Yeah, exactly. The intermediate representation is always the parent plus the bit that we're gonna have, like representing like B is gonna be plus
So
1.
why isn't that like a record or a tuple instead of being literally concatenated into it?
That's an awesome idea, man. I like it. I really like that. Let's
Uh,
do that. Let's do that. So, how do you do a tuple in Rust?
just the same that you.
The same in F sharp or in Haskell?
Yes, in F sharp. Oh,
Okay.
probably in Haskell also.
No, in Haskell is like this.
Yes, that's it. Oh no
Okay.
no no. Okay. You mean describing the type?
Yeah.
Oh yeah, that's it. And then you put the types. Where you?
Nice. So this is gonna be a string and bit. Do you have bit representation?
We probably have some stuff to represent better,
Okay,
but
so
we
let's
can
just
use
ask
U8s. But
bit. Oh, you want to use U8?
no, I'm saying we have U8s, but we
Okay, that
probably
makes sense.
because you see, if you are using U8, you always have 8 bits. Like,
Yeah, that sucks. That sucks. I want
Oh.
just one. One, and that's it.
Uh,
Okay, so we...
formatting?
Yeah, apparently... Oh no, it's just checking for formatting. This assert here. Doesn't matter.
That's not what we want, I guess.
But I want some sort of binary
No, no, no.
representation.
This is a trait binary, I guess. Oh, if it has the trait binary, you can print as a binary.
No, I don't want that. Okay. How do I print an integer in binary?
Maybe how to represent bits, I
Okay,
guess.
how to represent bits in Rust.
Okay.
Is there a 1-bit value type in Rust? That's a good question. That's actually an awesome question.
Oh, you could.
There's no primitive 1-bit type.
Hey, but I
Oh no.
know that you can represent with like
Boolean?
algebraic data types. No, not booleans.
Oh, that's
That's
fancy. I
fucking
like.
expensive at runtime, I guess. But you could do that. I know that kind has that, if I'm not mistaken.
Okay, so so it's a bad idea then.
Why?
No, because you said it's expensive.
No, no, yeah, I guess so.
Do we care? That's the question.
I don't know. I guess we would better off using U8s maybe.
No, because U8s will require doing like transformations and castings
But
and masks, and I don't want to do
no, no,
that.
no, no, not castings, but maskings. It depends because you can just okay. Let's shift to the left and then add one. That would be the same as a mask.
We can, man. Let's just use Boolean.
How
Or
can
do an alias for Boolean.
wait? What? How do you do that with?
No, because we are separating the concatenation. That's the key part. Instead of doing this plus in my that I did in Python, we are representing this entire thing as a tuple. So this will be like the CB, and this will be the representation of the bit one.
But you need multiple. Will it be like a vector of booleans?
No, will not be a vector of booleans.
You need more than one
No,
because you will be
no, I don't need
accumulating.
more than one. I don't need more than one.
Okay.
What I need, what I need is the following: is a way to put the symbol, right? So, for instance, here, what is ECB? No, sorry, what is CB? I don't know, but I know that it's ECB plus one. You see that we always just need a space for whatever doing.
Oh,
Yeah, B.
okay. Yeah, that's really clever. Yeah.
That's really clever. Yeah,
Okay, because
I wrote that down.
when you are like how can I say? Not trespassing. Well, when you are going to the list later, you can just do like on the
Yeah,
fly. Okay.
which means that I need to change this. So it's gonna be a new node. Oh, so much better. This is how we do true. It's like this. I have no clue.
What do you mean, man? Do you know any language besides like Lisp that is not? Oh, and C?
I know a few.
Really? That
Yeah.
it has not this true? Besides C and Lisp?
No, because some languages they use like they make booleans actually some not primitive, so they do like this.
Oh, okay. I see what you
Yeah.
mean. I see.
Okay,
Python.
so yeah. So we have languages that they treat these guys differently. Anyway, now we have a good representation for this guy.
Wait,
So,
just a second about that. A curiosity is only about the syntax actually, because for instance in JavaScript, it is like true as we are writing here, but when we press dot something, it has methods if I'm not mistaken, and you are like boxing and using the methods.
and this is wrong, by the way. Now this is correct because we are the
Okay.
hash is the key is the symbol, and then we are mapping that to a
Yeah,
tuple.
I believe that is bool,
Okay, interesting.
but I'm not sure though.
No, but let's use the bool with the not non-capital B. Let's continue doing this. After the insertion of the map, what we need to do, we need to update this guy to have the new symbol. That means that we need a maybe, my guy. How we do maybe?
What do you mean maybe? Option?
Yeah, we need options.
We have the options.
Okay, how we do an option? I want to convert this tuple to an option. An
Ah.
optional tuple.
Oh, okay. Okay, just the same, I guess. Like, oops.
Oh, they're just the same like this?
Yeah, I guess so.
Okay, interesting.
You have
And
to.
then we have to update these guys to sum. Is that how you do it?
No, I would guess it's like option.
Option sum?
Oh, no, 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 okay, you already have some, yeah. It's on the pervasives, I guess. It's like.
Yeah, but
open.
why is complaining about this thing?
Uh,
Interesting.
not sure.
Expected one argument, found two, apparently. Is this a lack of parentheses?
I don't think so, Lem.
Oh,
No!
no!
That's. Oh, fuck, okay, yeah. My mistake. That is not Okame or Aksha. You actually need to call some with. Right? Oh, no, man.
Yeah, this is
but
the.
But is it some right? Or do you need to. No, it's probably uppercase, yes.
Yeah, it's probably uppercase. Okay, but then the representation of this is awesome because you can just do none. Because we also need to put the new node in this. You see?
Okay, I see that you have none here because you. Why don't you have nothing here? I'm not getting it.
Okay, why none here?
Yeah.
Okay, so at this point in time, we know the representation. Are you looking back to on my screen?
Now I am.
Okay. At this point in time, we know that B is CB plus 1. Okay. And we know that C is CB plus 0. That's fine, okay? But we don't know the representation of CB at this point.
Okay. We are not sure if it will be on the left or on the right.
Yes.
Okay, I see.
And then, but this needs to be in our map.
Mm-hmm.
So then we are already like inserting it, but we're gonna like the recursion will take care of updating this in the future. Because now we're gonna do recursion, which I don't know how to do in Rust.
Just
by the way,
call it, I guess.
Okay, so then we're gonna pass the probabilities and the map, and then none, apparently.
Oh. What is the base case?
The base case is the. Oh, good question though. Oh, it's in here. We forgot. It's in the Python code. Go to my screen.
Okay.
So before doing any sort of manipulation, we check if the probability's length is less than 2.
That's not. Let me see, man. I'm not sure if that's right, Lemus.
That is right, man. Trust me.
No.
I already forgot how to do
No. Hey. Oh, you are doing Python, right?
Yeah, but look at my screen. The
okay.
tree finished. How many symbols do we have? The tree is done.
Okay, I see.
How many symbols do we have?
I see that we have 2.
Yeah, so this is the condition.
Okay, but I don't doubt your Python code. I don't doubt this image. I doubt our Rust code. Because see, we are inserting stuff and updating them, but we are not getting rid of anything.
No. What you mean by getting rid of?
Like we are not decreasing the amount of probability, Lemos. In the
Increasing the amount of probabilities. The pop is not doing that.
Oh wait. Okay, I see what you mean. Oh, okay. Oh, okay. I see. Now I see.
We are we are pushing, but we are removing like 2 pops and 1 push. We're gonna end at some point.
Yeah. Okay. Now I'm seeing. I was not remember of the.
How is the syntax of this thing again? Like this?
Yes, I guess so.
I think parentheses would be nice.
I don't even. Are you using the extension?
Which extension are you talking about?
Uh.
The extension is complaining about this guy first, so maybe that's the problem.
No. Like, how can I? Wait, is this right? Okay, one for option, the other for hash map.
Yeah.
Yes, the Rust extension, the Rust analyzer, I guess.
I am running that, man.
Okay, so when are you saving? Is he formatting? Like, okay, do this and save.
Oh! I saved it. and then it changed everything.
Yeah, because formatter,
Okay.
right?
Okay, so now it's working. We have the function that generates. Now let's change the name of this accumulate thing. So what's the name of this guy?
Uh,
Good name for it. Hmm. Because we are kind of creating the hash map along the way of this.
um, wait, okay. Lemurs. I
Right.
think we can do better.
What do
Yeah,
you think?
yeah, we can do better. Uh, yeah, like we can do this way of passing like a immutable map.
Mutable?
Wait, just a second. Let me. What's uh, do we really need this to be mutable to use the pop
Yes.
and such? I
No, this is not for the pop. The
no
pop
no
is this
no
guy.
like the pop and push and insert like all the operations that we are doing. Let's try to change this signature to
Okay, let's try.
like I know that can look silly, but I just want to be sure. No no,
Okay.
but it still needs to be a reference, right?
Oh, that's true.
Okay, are you getting any error?
Not. No errors.
But are you
I'm not getting.
compiling the thing?
No, I'm not. I do have the terminal here, but I'm not compiling. How do I? I already is
I guess that you can do like cargo.
cargo run.
Yeah, build or run.
Yeah. Okay. Oh.
Okay, yeah,
Oh.
we have a lot of stuff.
Okay. So it's complaining that cannot find value lowest in this scope.
Okay, this is concern. Wait, what is lowest?
Wait.
What happened with?
Something happened. Something happened in here.
Oh wait, man, something really strange. Can you control Z stuff? So but we can also just put it because we
Oh,
know.
here. It's here.
Oh, okay, okay, okay. Okay, I copied. Can you go back? Well, go again.
Let me just save the file. Then it's gonna do its. Oh, it's not doing.
Probably
What?
because it's breaking, I guess.
Oh. Oh, it's because it's missing the whatever the thing,
Oh,
the doohickey here, and then yeah, this is fine apparently. Now let's remove the mutables, right?
yeah.
Just to see. I do believe that these guys need to be mutable. I would be really surprised.
Oh, see, we don't need the parentheses. For some reason, he was not. Oh,
Okay.
now the formatter removed the parentheses before he wasn't
No, no,
doing
no,
that.
no. I didn't add. No, when I did Control Z, I also removed the parentheses in the Control Z.
Oh, okay.
Okay, in code line 18, it's complaining about this guy now. Interesting.
Expect
Rather,
such string found in non-result.
let's comment this function just for the sake of is it not interfering with anything else? This was compiling back then, right? I'm
Not
pretty sure.
sure.
Okay, so now it's complaining about in code. It's complaining about the hash map because I commented the code that it was using. That's fine. Next is mismatch type. So line 18 in here.
Okay.
Oh, we were not sure how to make a vector out of this element, I think.
Okay.
Yeah, yeah, I do think. Wait a second.
Why does it need to be a vector anyway? Like,
Oh, it needs because of this guy. Look at this.
I don't see it.
We have lowest.symbol.clone.push string.
No, no, no. That's a string. Just a string. Any string you
Oh,
can push stuff into it. It's
oh, it's
mutable
because
strings.
we don't have a string. We have a vector of U8s apparently. Yeah,
Oh.
yeah. The element is a U8. You see?
Uh.
We need to
Yeah.
convert a U8 to a string. I don't
Sure, we
know.
can do that.
Yeah, to a string.
But wait. What is this U8 anyway? Like a buffer?
It's a byte, right? So
No,
the
no.
element
I know it's a byte, but why are we using this as a type of buffer?
because it's the type that makes more sense.
Wait, where are we using this calculate probability? Like,
In the main.arch.
can you
You're
go
right, I
there?
forgot.
Go there.
Yeah.
Okay.
So you see, we have the file content.
Oh, that's supposed to
Uh,
be the file content, right?
yeah.
So not sure this will work, Lemos, because as
Oh, you
we
cannot
were.
convert the UA to a string.
No. We can do to a char and then to a string. I mean, the file content is weird to be like a thing of
Oh, this is the most
bytes.
generic thing for a. No, this is the most generic thing for a file content. It doesn't make sense to be anything
Oh,
else.
okay. Yeah, because I was thinking about, oh, you cannot fit a UTF-16 on the thing, but yeah, they will be separate bytes. But I got it now.
Because we need to, we can apply Huffman into images, onto text,
Yeah,
whatever.
we'll
But
have
we
to.
need a way to convert the U8 to a string. How do you do that?
Well, we can do it to a char and
U8
then
to
to.
a string
Uh,
rust. Okay. Oh, so this is the function that we are using. Nice. You need to do uncertain sort of unwrap.
no, the unwrap is because it returns a result probably, right?
Oh.
So you see str from UTF, and then we pass sparkle heart, and that's a vac of U8.
Okay, so this is a element as far as I can tell.
Mm,
Is that it? Oh, I know why we did this then. Because we are trying to make the vector with the
oh, okay. Because it
and
needs.
then we are trying to use it as a, oh, but it's missing the how to name it, this the reference, I think
Oh, is
this,
that it?
I don't know, let's see what
I
Calgo
don't
run,
think that makes sense. But why did you put a reference there anyway?
because it's exactly the same in the example.
No,
uh
no, 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 no. Wait, you are,
so it's complaining
you are,
about the
you are confusing something.
found, oh, okay, so this is not correct, makes sense.
Yeah, I think you are I don't know how to say that. You are confused about something. Like there, they are using that because they already created the vac, and then they want to just like uh borrow that value. But here we can just pass that. Yeah, and is what they expect. If you take a look on the types of from UTF-8, they are is expecting just a vac, like not a reference for a vac.
Isn't this a isn't Are you sure?
Oh, what the fuck? Okay,
Are you sure,
like
sir?
on my screen is what I see, but I think they have overloads, right? Oh, okay, I see.
Um. Okay, so oh, but this does not work. We already know that this does not work.
Okay.
Can we like? Oh man. Okay, so how exactly gonna make this work then? I'm confused.
Oh wait, man. Let's go to main and take a look on all of this.
No,
So,
but you don't have to go to main because we already know that the signature of this function buffer is a
well,
vector.
I want more context to
Okay.
know exactly what we want to do, and
Okay,
not
so
so
we
what
have a
we are doing.
file. We have a file name.
Okay.
Then we have the a vector of bytes that we are mutating because this starts as empty, but
Okay.
later on we're gonna add
This
things.
here is a supposition, right? Because
What
we
do
are
you mean by
not we are not really reading a file. We are creating this type. We are imagining that the file content will be this, right?
no, it's impossible to any file in existence to not be you read like this.
No, you are being sure about that. I think it's a fair assumption. Maybe it's a really good assumption,
No,
but
it's not an assumption. Any file can be read as a vector of bytes.
no, okay, but we are not literally doing like IO read file and seeing that the type that we will have is this one. But okay, let's leave it at this.
Oh, you're talking about creating the vector inside the read file function then.
Uh, oh, okay, I forgot. Because I didn't read the next one. Okay, then we are passing what will have the file content, and we are sure of the type because read file is requesting that. Okay, I see.
Yeah.
And the file name, so we have the file name, and we have the file content. It is mutable, and it can't fail, so we are unwrapping. Ah,
Ignore these number elements. It's
okay,
not
okay.
important for now.
Uh, are we going to need this?
Yeah, in the future for error handling, yes.
Oh, okay. Uh, then we are printing the file content.
Just to see if things are working,
Oh,
and then
and we are actually reading the file, right? You already.
yeah, we are actually reading the file.
Oh, okay, okay. You already printed the thing.
And then we are
So
calculating the probabilities,
okay, okay. Here it
and then you're gonna encode
goes.
the thing, which is fine.
Wait, wait, wait. We are passing a mutable reference of file content. That doesn't make sense.
Um, Justify.
Well, we don't need to change the file content.
No, it's because it was mutable here. We could just do like this.
Oh, that. Oh, okay, okay. I see, I see. It doesn't let us, right?
No, we could. I think we actually
Could
could.
we?
Yeah. Because we're not mutating it in the function calculate probability, actually. We are just reading it, as far as I can tell.
No, no. It's because we have some rules in Rust that you cannot have like. How can I say? A mutable reference to it and a mutable reference to it at the same time. And why is that? Because, well, one is assuming it's immutable, but the other can mutate. But there are exceptions when you, oh, okay, when I reach this point and I'm using a immutable reference, I'm not using a mutable after that.
Okay, no, okay, that's fine. We can change the mutation after. So that kind of doesn't matter.
Uh,
But
but if it let us like use the immutable one, we just should it already. But
no, but we are trying to find problems. I advocate to not find problems. This thing was working like this, so let's keep it.
okay.
Why and why? Because we have worse problems to handle, right? This is not compiling anymore.
Okay, okay. So we have the number of elements. That's where we are using this. So we can get like the relative stuff, right?
Yeah. It is because we want to know the probability, so we have to divide by the total.
Okay, so let's inside calculate probability.
And okay, all of this is just to have some context of what is a buffer. Um, the buffer is already in here. I think the type signature was enough. And then we need to transform this U8, these like 8 bits. We need to transform this to a string. That's the goal, and that's what the compiler is complaining about.
Okay, okay. Why do we need to transform this to a string though?
Because we want to do this later.
These what? Wait, I think I'm not following you.
Okay, sorry.
Okay, now I see, I see.
Okay, so the symbol in the new node will be a concatenation of two symbols.
Okay.
So this can be or a vector of U8s, which I don't advocate for, or a string.
Okay, okay.
And then we need to convert this guy already to a string.
Okay, fair, fair.
How we do that? Because apparently this way is wrong.
Okay, I will just take a look on the type of. Whoa, it's better you go there, then I can see it because I'm following you. Binary heap node. I want to see the heap node, right?
Here.
Okay, so the type is a ordered float. Like this other thing is just for us to be able to use the heap, right?
Yes.
And the symbol is the string that we want the UH to be in, and is a string because we have to concatenate and stuff. So we are trying to create this heap node. So go back there.
The probability is fine apparently.
Okay, so
but the symbol requires.
Okay, so here we are creating the heap that will return. Okay, that's just fair. And unique elements. Why do we need them? Okay, okay, the unique ones because okay, I see. I see why the unique ones, because we want only the unique ones to go on the map, right? And
on the heap edge, actually.
yeah, the heap. So then we go to those, receive the reference of the U8, and then we're supposed to be creating the new node, and then just pushing there, okay? See out there? Probability.
No, but the problem is in here, man.
Okay, I'm reading everything because I don't remember about this. See?
Okay.
It's a problem if you want to add new stuff without knowing what is there.
No, but in this particular context, you can just trust me helping me getting this string.
Okay, okay. Uh,
Later we can do a little bit of recap.
okay,
Because it's already one
maybe.
hour passed through, man.
Okay,
Already
so
passed an hour.
maybe this from U8 is not our best choice, man. Raw
Whoa.
parts. What is raw part? Unspotted markup content received. No, that's really strange. New. Wait. We can do strings and push chars, I guess. We can do like. Oh, okay, okay. New string. Okay, let's see that. So let's try to create a new string here, right? Like, let full bar. You can do a better name in the meantime if you want to. So here, and then okay, this needs this, I guess. Okay, then we can do like full bar dot push. Oh, I see, and that's a char. Okay, so here we could pass a char, and I would bet that element has something to go from UA to a char, I guess. So we have two ASCII, to be bytes,
Okay, let me try to find what you're trying to do.
two string. Oh no. Uh,
Oh, so there's a way to do it directly then.
yeah, that
Is
would.
that a thing?
Let me see.
Is that a thing?
Yeah, that's a thing apparently.
Oh, okay, so we can just, instead of doing whatever this is, we can just do element. I don't know if I trust that though.
Why? Well,
Usually,
it's a U8, so U8 is a number, right? Then they will literally like pick this number. Is that safe for the things that we are planning
no,
to do
that's,
later?
wait,
Hmm?
not entirely sure. Is that fine? Hmm,
For instance, if the well, you already understood, right? So
yeah. I never did like that. It would be better to have like actually like a. Let's try it. If we have an error, we can go back to this.
okay, we can also do two ASCII, like two lowercase ASCII.
Oh, I see. But let's try to run it first. Okay. So expected string found str.
Oh wait, will
Oh, so you need to do that conversion that you always. How do you convert some to one str to another one? I always forgot.
not sure what you mean. I'm not seeing the error.
You see, are you in the Visual Studio Code?
Yes.
So you told me that there's a difference between this and this.
Yes.
How we convert the first to the second?
Wait, but I'm not seeing the context.
Oh, this is wrong. This is the context.
But here it's
Because
saying
this.
for me the symbol and the result of two string they are the same time for me here. Can you show me the compiler error?
Yeah, it's already on the screen.
Okay. So expect string found as. What that? Man, that doesn't make sense to me. I'm seeing. Like, can you see the types on your? Oh, okay. Is that the problem?
Let's try. Yeah, it was. Okay.
Okay, nice.
Expected heap node found struct reverse. Which mean
Oh, that can be a
God,
problem.
this will add a new type apparently. Okay, so let's go to
Wait, are you
heap.
sure? Can you go to that document? Oh, you are going there, right? Yes,
What
because the
type
way
of
they were doing.
reverse? No, but it's the same. Oh,
Uh,
it's because you don't have. Okay. Nah, okay. Okay, so
Verse, okay, I see.
this should be. Oh, it was already here, man. Yeah, so I don't know why it's complaining. Because we have a binary heap, new.
Oh man, that heap doesn't have a type.
What do you mean?
So if it doesn't have a type, it could be supporting the type reverse. You see? We are not.
Oh, we need to remove the type annotation of this.
Ah,
We could. I'm not saying we
yeah,
should.
we could.
But let's see what the compiler complains now.
Let's see what type he gives us, because it will probably not be binary heap
Okay,
of
okay.
heap
It's
node.
complaining now that the type of heap is not the one it's expecting. Yes, we need to change this, unfortunately. So this now will be a reverse heap node, which means that I can. How can I do auto completion with this thing? Okay, okay, okay. So we should have everything compiling. Still not compiling.
There is.
Wait.
Oh, all the places, man.
Oh, okay. It's in here, which is fine, I
Oh
guess.
man,
Yeah, this doesn't make.
this reverse on the heap thing is a terrible API, man.
Is that the reality? Nathan is complaining about Rust.
Uh, sure, why not?
What the? 32. What?
We have a
Oh, here
folder.
we have a fold. Probabilities dot iter fold initial value accumulate local entropy.
Why by a...
Accumulate. Oh, this is this function right here.
I have no idea what is this note.
Wait.
Ignore the note. Yeah,
Oh, it's the
ignore.
reverse. It's the reverse. Whatever. Mm-hmm. Oh, so it's complaining. Oh, it's the type of this. This should be reverse.
Oh, I wonder when we want to use this heap node. Like, do we need to do something different
What do you mean?
to get this type from inside somewhere? You see?
Unknown field, apparently. Uh,
Oh,
oh, it's
okay,
because
I
the type of the
see. Right.
element. It's because the type of the element now is not as zero. No.
Oh yeah, man, that's also very bad. Like they are literally saying, "Oh, okay, this is a tuple," and right, you can adjust access.
Oh no.
Oh yeah.
But it's working, I think. Uh, no, it's not. Oh, that's
What
sad.
is not working?
This is in the wrong order, I think.
Mm.
Almost sure.
Can you take
Because
a
it's
look on the pops?
yeah. So we can pop. So we have the probability. We can just pop this guy 3 times, and we can comment this line out
Oh, okay.
and see what happens. Cannot borrow as mutable.
Mm.
Apparently, this needs to be
Oh,
mutable. Is
no
it
no no
talking
no
about?
the dot pop here it needs to be mutable. Yeah.
Yeah, so
That
that's so that needs to be mutable, unfortunately. Which makes sense. Like it makes sense. I need to be honest. Okay. Oh no, it's correct. Yeah.
okay.
So the print is just a little weird, but it's fine.
Oh
Uh,
man, that symbol as a string of the number of the U8 is very weird, man.
okay, but now we can finally uncomment this function and see if things work.
Okay, heap node is not heap node anymore.
Yeah, it's a reverse heap node. Like this, which is okay, I guess. And let's try. It will try. It will compile even though I'm not calling this function. It will type check, right?
Not sure what you are saying. It will
Okay,
just
I'm
give a
not.
warning of unused function if I know what you
Yeah,
meant.
but it will try to type check this. We
Uh,
will try.
I guess so.
Okay. Haskell things. Haskell things. Okay, it tried. It tried. Yes. Okay. Let's start from the beginning.
Holy fuck, that's.
Oh, it's the same problem.
Oh,
It's the same
elements.
problem. It's the same problem. So this has to be, oh man, 0. Oh no.
Oh no. Like even though I think Rust is a great language if you are doing low level stuff, I realize that I don't like to do low level stuff.
No, low level stuff is fun. I like.
Yeah, I don't.
I really like. That's why I want to try to go, by the way.
Yeah, that's a terrible idea. Well, if you want to learn good languages, if you just want to learn language, like, then it's okay.
I don't know if I trust a hater. I really don't.
Oh, you can try it, right?
Uh, especially after hearing good comments about it.
Okay.
Like I know you guys say bad things about it, but I also heard good things about it.
Sure, you can just try it, man.
Let's try to compile this. Okay. Still bad. Oh, I did in the wrong place. Wait.
Um.
Wait.
Oh man, this is too funny. Take a look on this.
Yeah, no, I saw.
Holy
I
fuck.
saw.
No, but
Oh,
this is
man.
also terrible. Like, so
Yeah,
many
this is really bad.
parameters.
Yeah, but it's complaining about something that I don't understand. Wait.
String.
Expected struct string found unit. What do you mean, brother?
Ah.
What do you mean? Oh, this is already a string, right? Oh no, this is to convert the string with capital S to this. Okay.
Use
Um,
method types. Let me take a look. Symbol.
expected struct string. Expect
Oh.
found unit. Found unit. What do you mean?
A push str. Oh, the result of push str is a unit, man. So we need to do this before.
Wait.
Oh, okay, okay. The clone, we are pushing into it, but not returning it. We need to do this before.
No, that's not gonna work. You need to do that inside this scope, man. I think. Maybe I'm wrong.
No, we don't.
Okay. Oh wait, sorry.
So we can just like, uh, yeah, it will be the.
Oh no! Wait, is that what I think it is?
Wait, let me just type it because. Oh man, that's so fucking ugly. Uh, and then we can do like here, just foobar, but we need this, like
Okay.
bar dot this, like this, and one dot, and holy fuck, is this even working?
No, I think it's completely bugged. Lowest symbol.clone, and then you're gonna do new symbol push.
Uh,
Now I think it's correct. Yeah, let's try. Oh, this is a song that has a guy talking. I need to push. I am
oh,
skip.
oh, new node. Wait, what is new node? New node. Where are we using new node? Oh, okay, okay. We need to wrap things in reverse, right? When pushing. So how do you wrap this again?
Good question. I think it's just like this. Line 20.
Oh, okay. So literally this.
Yeah. Yeah, it's complaining about that. Unknown field apparently on line 57. This
Uh,
not 100%
yeah, because it was a
sure.
new node, right?
Oh,
So
like okay. Wait, what?
uh, it is a
I'm confused.
like look at new node. It's only heap node. It's not reversed yet.
Oh, oh man, but that's
Why
okay.
that's not a
Okay, no,
problem?
okay, okay. That's bad. No, that's not bad. That's not bad. Not bad.
Well, it
Actually, I
is
prefer
bad.
this.
It
No,
is
no, it's not
bad.
bad.
It's just not a
No,
problem.
no, it's not bad because you're gonna get rid of the reverse after this step.
No, we are not. Like because it's the same type.
No, you're
Look
gonna
what
discard.
we are pushing.
Yeah, but you're gonna discard probabilities after.
Oh, okay, okay, yeah, yeah, okay.
So
You're right.
only the map matters at this point.
Oh, yeah, that makes
So it's
sense.
complaining about expected string for some random reason. I'm not entirely sure. Oh, it's just because this is
Of
wrong.
course.
Because we need symbol here. Compiler, are we good?
Sorry. Good.
No, we are not. Nice.
Uh, oh man.
Oh, this brought up a bunch of
No,
new
no, no.
errors.
What the? How can we have that many errors?
What the? Let's go back
Oh,
to this
probability is
implementation.
a reference.
Wait. Yeah, probability is a reference. It appears. Okay, so map insert expected string but found
Okay,
heap node.
let's put mutable here, just because I think that maybe we'll
Okay,
get
that's a
rid
good
of
call.
some types.
And this guy is complaining about not having symbol apparently. I don't know if that makes sense. Let's see. Okay. Does not need to be mutable apparently. Oh no, but it's just a warning. That makes sense. Okay, use of moved value. So we are value moved here.
Oh, okay, okay. You can remove probably because you are not using later.
Wait. I don't understand this error, man.
Oh, okay, okay. Maybe I can help with this, but man, go to the first one because, right?
Right here.
Cannot
Consider changing
borrow.
this to be mutable.
Okay, wait just a second. Cannot borrow new symbol as mutable and is not declared as mutable. So new symbol. Okay, new symbol dot push. Oh, okay, okay. Let's just put mutable new symbol.
Yeah, it's saying to put mutable here
Yeah,
apparently.
let's do that.
I don't know why yet, but
Probably because we are pushing. Not so sure.
oh no, makes sense. Makes sense. Now it makes sense that we are pushing.
Okay, but let's go to the first again. Oh, that's a lot less now.
Move occurs because new node has type heap node, which does not implement the copy trait.
Okay.
What this means?
This means that there is not a type that you can just copy around, like an int, for instance. So if you want to copy it, you have to like clone it, right? And well, if you are not doing that, you are moving the value. So you cannot use after that because you move it. It's responsibility of other variable now.
Okay, we need to clone every single time.
No, no,
Then.
no, no, not necessarily. Uh, well, of course you can do that, but you could also like see the root of the problem and do something else if needed.
What would be another alternative?
Not sure. I have to see the problem first. Let me read it. Like, move occurs because new node has type heap node. Okay, the line below. Oh,
Yeah, it's
probability of
50.
push. Okay. Do we do something with this new node?
Yeah, we do
Oh, okay, okay.
4 things. We first push it to the probability heap, which seems fine.
Okay, okay. We do need to clone it somewhere, I guess. Yes. Because I don't.
Oh, here you
I
you
don't.
think here?
Uh, yes, because I don't think we can get just a reference of it. It has to be the item. So.
Okay, so clone it here, and then we are also adding it. Like we are using to add into the map 3 times.
Okay, but that's the thing. Like, if you are cloning, like here, right?
Oh wait. Wait. Oh, we don't need to do this. We can just do this. Nice. That's better.
Okay, nice.
Okay.
Wait, aren't we using anywhere else now? If we are not, we can just not clone it anymore.
Okay, let's try that then. Um,
Oh, a lot less errors.
okay, value borrowed after move. What
Okay,
that
so
means?
the same thing, man. Exactly the same error. But what is happening with new symbol then? like new symbol, it's here. It is mutable. Then we push same thing. Oh, it goes inside. Oh, it goes inside here. It goes inside new node, right? This is the
Yes.
move that they're talking about. If you moved something, you cannot use it later.
Why?
Why? Because otherwise you would be too freeze. Like the one that is responsible for it, you will be the one to do free when it left the scope. So you would have like a
Oh,
bug.
there's a race condition in the one that for who will be the
Uh,
one fearing this thing.
no, it's not a race condition. You know when things will happen. The thing is, the way they deal with like allocating and freeing, and let's talk only about freeing, is that one variable is responsible for a reference for a given like memory space.
Interesting.
So you will free that one. So if you do that reference to another variable, you cannot use it later because the new variable now is the responsible. He will do the free. If both would do it, then would be a bug, right? To freeze.
No,
Then
no, so it's related to what I said. So we don't know who. Like we have a problem of okay, two freeze is gonna be a problem.
yeah.
Apparently.
So that's why they implemented this called move. The way to circumvent that is that you can borrow, right? You are not giving, you are borrowing. See?
Just let me check this. Okay, okay. So it fixed it. I moved the manipulation to before doing this, before the move. Let's say.
Yeah, see, it's because you are not, how can I say, you are not moving then using. You are using and then moving. Then it's not
Exactly.
a problem.
But I think I want to reverse this change because I want to know how to borrow stuff.
Okay, borrow stuff is passing as a reference. But I'm not sure we cannot do in this case. We cannot do this in this
Yeah,
case.
that's we can't.
We would need to clone it here.
Yeah, no, but let's not do that. Let's. I don't think there's a problem reversing the order of this thing. So it's fine, I guess. Okay, so this is compiling, which means that you can execute this.
Oh.
So let's go to the main.rs. Let's create a mutable hash map. Empty, right? Empty. So let me pick the hash map reference in here. Let me clone in here. How do you create a hash map? So this is going to be a test map.
Okay. Do the type.
Okay, the type is
No, not there on the value. We want to use a method of it, a static method.
What do you mean?
Type, the name of the type,
The name of the type,
and then colon. That would be a static method of that type.
Oh, I remember now. Okay, it's the same thing that we did with like IO or something.
Yeah, but in that case, it's accessing a namespace of a module. In that case, okay.
It's like this, right? It's like this one?
Yes, exactly this. The same.
Okay. How we do this new?
I'm not sure. You would have to see on autocomplete.
I think it's new, but I need to put the type signature. So let's try.
You could also put that. You could also put that here instead of type annotating. You could put on the call, but it's like ugly as hell.
Okay, so I think this is the way that we want.
Holy fuck! That's also really bad.
No, we can rename after.
Yeah.
I want to finish the encoding today, though. Let's go. So now we call the function. How we do that again? It's gonna be encode column accumulate hash map, and then you're gonna pass the probabilities and the reference of the map. Yes, it's gonna be a reference mutating the test map. And then we can just copy paste this guy real quick, and then just do test map.
Do we have a debug implemented for that?
No. That's it. Sorry, I don't know.
Well, let's execute then.
Let's see what happens.
Okay, we compiled and printed the thing.
I think it worked.
99, it has some. That's pretty.
Wait. Uh, wait. Done.
Well, we only have three. That's right.
How many symbols? Text dot test dot x. We're gonna have three nodes because we have only three bytes, A, B, and C. So this is already
Wait,
kind of.
Lemus. Let me modify something on the code. Because I think the.
What are you laughing
Oh
about?
my. Man, this. Wait, I will do the modification and then you will see
Okay,
it.
go. Let's do.
Where are we using U8 to string? Here,
In
right?
here.
Okay. Let me take a look on what this gives us.
Oh, this is not gonna work, my friend.
Oh, this is given
This.
a U8? Oh no. Wait. Wait, element? Oh, okay, element is the U8. And we
Yeah.
want that to a char at least.
No, not necessarily. Not necessarily.
No, I want to see that as a char, man, because it's just a lot easier to debug, Lemos.
No, I know, but let's not change this function then. Let's continue with
Uh,
the toString and let's change this thing somewhere else.
what do you
Uh,
mean? That's where we are going, like on U8 to literally the number that it
I know,
represents
I
to a
know,
string.
I know. But the thing is that sometimes you're gonna have a byte that is not representable as a ASC symbol. It's a
Okay.
Unicode. It's like essence and stuff.
Okay.
So we
I
changing
don't
this rule.
think we have a type for that.
No,
Yes.
but that's the thing. We don't have to have a type for that yet because we can. In terms of debugging, having numbers is bad. It's bad. I agree.
Really bad.
But I think we can. If you want to see the letters, you can just change it here.
Uh,
Like we can
change
just change it in here.
change it
This line here,
where?
48.
Oh, okay. Let me follow you. Okay, I see.
Because here we are doing concatenation, right? We are picking the 99 and concatenating with the 98. For debugging purposes, I think here is less terrible because if you change this, you're gonna forget. If you change in the symbol in the calculated probability, we're gonna forget that we are using ask, and then when you have the Dom Casmurro test, things will break and you're not gonna know why.
Okay.
So let's just change this line here, 46. But before that, I just wanted to see the letters, man.
Uh,
Uh,
wait.
okay, so if we have,
Lemus, I think that what you said it technically doesn't apply because the char is also a U8, even though you cannot print the ones that are after like the 127, I guess, something like that.
oh, I
Uh,
think it's 155. I think it's 8 bits, not
no,
7, not
ASCII 7, right?
ask 7. How many numbers you can represent with 8 bits? Oh, it's 8 bits, man.
Okay, more like than double, right? But
Yeah, you can
that's
255, I think.
no. Okay, let me clear. Like, the original ASCII table, they have like only like 7 bits, if I'm not mistaken. But the char, it uses U8, if I'm not. It uses 8 bits. So even though you are representing a char that is unprintable, because the ASCII equivalent doesn't have
Yes,
it, the
yes.
representation is preserved. So if you convert that to a U8, you will have the right one. But yeah, we don't need to go to this trouble now.
Okay, so one thing that we can do, um, go to main.rs just for a sec.
Okay, I'm following.
Um, there's a way to us to check this real quick, and that is to just open like and do like this. This is 97 because you have only 3 characters, man. This is not gonna be like the end of the
Oh,
world.
okay, I see.
And C is gonna be 99. Okay. So now let's calculate the probability of. Oh, we don't have to calculate, right? We already have in the print. So the probability of the letter C. Let's start in order. So A
Wait, where are you look? Okay.
in the terminal and in the main.rs. So the letter A, it has 0.416 probability, and the B, which is 98, it has 0.33 probability, and C we have 0.25, which is okay. So let's try to make this tree ourselves, right? So this will be iteration 0.
Wait, you are testing the probabilities?
No, I'm testing the algorithm so we can know the result. Iteration 1. Iteration 1, we're gonna combine the two least probable
Oh, okay, I see.
guys, right? So we're gonna have C and B combined, apparently. So we're gonna have the same thing here,
Okay. Which one
like
will
this.
be on the left and on the right?
That kind of doesn't matter.
It
That kind
matters
of
for the 1 and 2, right?
no.
For the
It
true and
only
false?
matters for we need to be consistent. If we pick, uh, go to my screen that I'm sharing on Discord now.
Okay.
Flip all these bits. That's what this decision makes. Instead of 0 0, it'll be 1 1. Instead of 0 1, it'll be 1 0. You see? You
Yes.
you're just like flipping horizontally all these guys. So this is still intact. Like this the property of the tree that the Huffman algorithm uses is still maintained.
Wait, Lemus, but what I'm saying is we need to know which choice we made to check the thing, don't we?
Oh no, we know. We need to check. We need to know. That's correct. That's 100%.
So you have there on the push, right?
Um,
So let me see.
okay, so
The lowest you are pushing with true.
wait a second, man. Wait a second. B. Okay, so B will be. Let's try to decode B. B will be BC. I don't know. Let's start with which is the lowest. It's C. C in the code we are adding true. Okay,
Yes.
so B is gonna be BC plus 0, right? And C will be BC plus 1, which is okay.
What the
Let me
fuck is
convert these zeros
that,
to
man?
false and true. Okay, so let me
What the fuck do you mean by BC is equal? B is BC plus false. I don't get it.
okay, so let me try to explain to you. So in the
Oh,
first phase,
I'll see. You are talking about traversing, right? And
yeah,
make
I'm
that.
trying to find if this answer
Okay,
is the
so
correct answer.
BC is the accumulated and false is the next one that you will.
Yes,
Oh, okay.
yes. Because we want to try to match this, because now I'm going to convert. 99 is C, right? 99 is C, which is okay. 9998 will be CB,
Mhm.
and 98 is B. So this will also be CB, CB like this. And then we have CB here. Okay, so look at this dictionary. C
That
is.
makes sense to have CB here and here and.
Yeah, it makes sense. I will explain to you shortly. So C, what's going to be the final bit representation of C? It will be whatever CB is plus 1, which is exactly what we want.
Oh, I see.
What will be the final representation of B? I don't
Oh.
know, but I know it will be the bit representation of CB plus false, which is
Okay.
exactly what we want. Which will be the bit representation of CB? At this moment in time, I don't know.
Huh.
Then you may ask, what about A, right? We are missing A. A, we are not seeing it in this dictionary because our stop condition is probabilities less equal than with 2, right? And this is the final result of probabilities, A and BC.
Okay.
Okay? So, this means that in order to see A, we just need to print the probabilities. So I'm going to do that right now. Calgo run. And okay. So we are first printing the map. So this is the same map that we were looking at.
We need labels.
Yeah, no, we need labels because of the character to like the byte to character number to a mapping. But anyway, this is the same map that we were dealing with in my explanation. And then we have here, right? We have it. We have the remaining of the probabilities after all these pops and pushes. So if you look at here, we have two guys only, right? We have only this guy, which is the number A, which is the letter A, and we have 99, 98, which is CB,
CB. Okay.
which is 0.58, which is
Okay.
exactly what we want. So it's C. The function is working as intended for us. What is the next step? The next step after this is after calling Huffman code, this right here, my friend, these 5 lines, this is picking the A, like the remaining probabilities that we have. In this case, in this particular case, will be A and B, C, right? And we are already handling them. So okay, A, I don't know, A, it's gonna be this. It's gonna be the bit 1. And why I say this? Look at this visual representation. Imagine that this is A. Imagine this is BC or CB in our case, right? These two guys, they are like they will be the beginning of the entire thing.
Okay, Lemus, but why don't you do that if it's possible inside the recursive call and just stop when you have like 0 probabilities in there? Why are we?
Because the algorithm is not the same. Look at what we are doing here. You see, we are doing with the lowest, we are doing a concatenation with a new symbol and a 1. This is not doing that.
Mm,
We are defining A as the, like, you are the most, you have the most probability. You're going to be represented with only 1 bit. So the
okay.
most recurrent guys appearing in our sequence of bytes, they will be represented the bit 1 and the bit 0.
I still think we are able to do that inside the recursive call, but I see what you mean.
Okay, we can actually do that. You're actually correct. We can do it right here if you're following me, right?
Yeah. Wait, not
Uh,
okay.
so let's call this guy potentially the last. I will explain why the potentially shortly. So this will be the same as this.
Mm.
This will be the same as this, right? And then we're gonna do the exact same thing as the insertion guys,
I'm very
right?
curious about the potentially, man.
Okay, you're gonna see, right? You're gonna see shortly. Uh, we have the map, and we're gonna map what? We're gonna map this potentially last instead of all of this. Probabilities, yeah, we need to unfortunately the 0, which is really sad. This is gonna be none of this. This is gonna be empty, and this guy is gonna be true. Yes, 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 yes. I think I'm missing parentheses in the middle of this thing. Okay, makes sense. And then, why this is the potentially last one, right? Why this is the potentially last? Because maybe in the remaining of the probability heap, maybe we have 2 guys, or maybe we're gonna have 1 guy. This depends on how many characters we have in our alphabet. If you have a odd number of symbols, we're always gonna have 2. But if you have an even number of symbols, this will be the last one.
Okay.
So you need to check the length of probabilities. If this is equal to 1,
Yeah,
uh,
but please don't nest that. Just put it outside and do your thing.
what do you mean outside?
Instead of doing if inside of if, you could do if is 1, I do something. If is still, like, still has it something. Uh, like, okay, you can go on like this, but
We can refactor later. Then this will be the last. For sure, this is the last. But this is going to be the bit 0 because this is the second most recurrent guy. No, it's the opposite. Sorry, this is the potential less is the second most recurrent, and is the greatest guy in terms of probability. This is the greatest of the greatest. So now after this,
Wait, man. Uh, so it could be. That's is looking weird to me in the sense that okay, suppose yeah, suppose this could be the last, right? Like if you're correct here.
yeah. Suppose this is the last, then
So
this if will
okay,
not true.
then it is true. But then if this is the second, this is still true. Is this alright?
Yeah, this is alright. You know why? Because there are two atomic representations of the for the two cases. You can be a 0 or a
Oh,
1.
it doesn't matter, right?
Yes, doesn't matter. That's one of the beauties of this algorithm. It kind of doesn't matter how you do. It only requires you to be consistent. If you mess around with the branches in these two lines here, for instance, then it will not work. But if you want to flip, oh, left is 0, right is 1, or vice versa, it kind of doesn't matter. Okay, let's test this. We don't have to print probabilities anymore, I hope. Actually, gonna print just to be sure. This should be empty
Yeah,
at this point.
put labels.
Oh. Okay,
Oh,
so
okay. That's yeah, the type.
Okay, so how you do an empty string?
str new. You can just.
Are you oh, like this. Okay. Environment variable
Oh,
display a
panic.
backtrace.
Oh, some
Panic.
unwrap that we did.
Wait.
It bites us on the back. In code line 51. Like, we use an unwrap and it bites us on the back. Go on.
Oh, it's because you're dumb.
Not really. Go on.
Yes.
Encode 51. Oh, okay. Yeah. Actually done.
No, but it didn't work. So there's something more than just returning.
Yeah, go to encode 51. That's what he's saying, right?
Encode 51. Is this line right here, man?
Okay.
Interesting.
Yeah, then the return should be working because the lowest he pops, it doesn't have anything. Then we unwrap is an error. But if we are returning, I don't see the problem.
Let me try again this. Maybe it I don't know.
Did you
saving
save
was not
it?
synced.
Oh, okay.
Oh, now it worked. Nice. Okay, so let's try to read this again and do our simple conversion because it's only 3 characters, not that big of a deal. So
Like
now
wait, we already have the final mapping. No, we don't, right?
No, we don't.
We have to do it.
This is the final. This is the one that I'm gonna add here. This is the final representation. So we just have to switch from 99 to A. This will be AB.
No. I mean like character to the beats that we will.
No, I jump one step at a time, man. 99. I'm just being dumb here. I already forgot the numbers. This is A, and this is okay. This is correct. And then we have 98. 98 is B, which is okay. This is CB. 99, 98 again. Well, yeah, I think this is, I don't know. And this is CB. And yeah, okay. So let's go one by one. So as we established after iteration 1, this will be the B will be what? Will be BC or CB, doesn't matter, plus false. And if you search for B, which is in here, this is CB plus false, which is fine. And C is BC plus true, so CB plus true, okay. A is gonna be the bit 1, right? Yeah, it's going to be the bit 1 because it's the second most recurrent guy in our exercise. As you can see, like 0.41 is less than 0.58. And then BC, which is now here, will be the bit 0, which makes sense.
Okay.
Okay, so this is 100% correct. Now, what we need to do, and I don't know if we want to do that today because you have only 10 minutes, it's just we just have to do the translation because we don't care about CB. Remember, CB is just a imaginary symbol representation for us just to make the tree itself. We need to do a second pass translating these. Oh, CB plus true. I'm gonna discover what CB is. Oh, CB is 0. Okay, so it's gonna be 0 plus true, and so on and so forth. You see?
Yeah, but I don't see how we would do that.
Okay, so let me explain to you how we're gonna do that.
Go
I can
to the
explain.
image, right?
Okay, we're gonna do an iteration across all the dictionary. Okay, and
Okay.
we're gonna search. Okay, I have C here. What's C? Oh, C is CB plus true. What's CB? Oh, it's here. Okay, so CB is false. So I'm gonna substitute this by false.
Yeah, but we have to take a look on this condition, right? Of not having a string. Like that's we.
No, yeah, we're gonna have to check. No, we're gonna have to check actually. After this step, this is actually a clutch moment as well. After this function that we did, accumulate hash map,
Oh wait,
I
wait,
can
just
guarantee you that CB is in the dictionary.
okay. Just one thing first. Where are we using the non case exactly?
The none,
Yeah.
we were using it here. No, not here. Here. I don't know if you're still following me.
Okay. Yes. To introduce a new one, right?
Yeah, to introduce in the dictionary the new symbol, just created symbol, which is
Mhm.
okay. And then here in this if uh, leaf less than true, this is where we are updating it to something like false and true instead of
One thing. When we insert this node with none, do we already know if it should be true or false?
no, we don't.
Okay, so that's okay.
We don't. Okay, so the algorithm is pretty straightforward actually, in my opinion. Like I think we can do it in 10 minutes. We just have to iterate across all of this and do some sort of, okay, what is C? C is CB plus true. I know for a fact, I can guarantee you that I know this dictionary contains CB. CB, I will find it in the same dictionary, and I just have to put this false value in the place of CB. See?
Yeah, but holy, that's expensive, man. Like,
Oh yeah. Oh
that's
yeah.
really expensive.
And there's a problem. There's a potential problem. Let's suppose that this, instead of CB, is CBAFG.
Hmm.
Okay. You're gonna have to search about this bit by bit, because this is a combination of multiple imaginary symbols. You see?
What do you mean? You mean like, okay, we will see this and we will like get a part and search for it, or you mean, oh, we will go through the all of that and that will lead us to others and others and others? What do you mean exactly?
Go to the screen that I'm sharing on Discord.
Okay.
Um, do you see that to discover what is CB, I will have to discover what is ECB?
Okay, I see.
Okay. To discover what is ECB, I will have to discover what is a ECB.
Mm-hmm.
You see that this can be huge.
Yeah, it's not as bad as I was thinking, but yes.
Yeah, so this is the trade-off that we are making. So when you're calling for something, maybe you're gonna call and call and call and call and so on and so forth. To the in terms of computation, it's really heavy, but in terms of writing the code, it's really simple. Really simple.
Okay, so let's go. Let's try to make it quick.
Okay. But there's a gotcha then.
Hmm?
Go back to my screen.
Oh,
There's a
what you
gotcha.
mean your screen?
Oh, we don't have the gotcha because you're using tuples. Oh, that's so nice. That's so nice. Because this gotcha here that I made in
Yeah,
Python,
it was accursed stuff.
cursed stuff. Oh man.
No, that's literally the type of thing that we do in JavaScript or PHP, like concatenating strings
Okay,
and
okay. We
numbers.
don't have to care about the exception. That's so nice. Okay, let's go to the encode.rs though, and
Okay.
let's uncomment this function right here, and this will be translate symbols. Just for now. Maybe we're going to change our minds. We don't need the probabilities, which is nice. We don't
Nice.
need. Um, we just need the hash map. So I'm going to just copy paste this guy right here. This will be the dependency, and what's going to be the final thing. Let me check. Let me check.
A better
Okay.
hash map.
No, no. We're gonna have to have a new another guy here, which is really sad. I'm gonna
Uh,
explain you why. I'm gonna explain why. Unique
mm,
elements. What are these guys? Actually, it's not the unique. Is like requested. I think something like that. Because
what
we
the?
don't want to translate the CB. Go back to my screen. With these symbols right here, like the known leaf ones, we don't care about them.
Okay.
We just need them to do the bit to have the bit representation. But
Okay,
what
see.
we want, I want so the requested elements dependency will be these leaves, but we don't know their representation. We are just we want you to
Yeah,
find
I
these ones,
see that, but
and then the map, the hash map, will be the thing that this tree. And then instead of returning the entire bit representation of even the symbols that we don't want, we can just filter the ones that we want. So this function will return step 7.
oh, I see. You pass the unique elements, then you filter the others.
Yeah.
Oh man. But that after calculating all the.
No, but we can calculate it easily. We have a line that does this already. In some here. Line 11 on
No,
encode.rs.
no, calculate that I mean is going through the tree multiple times to see the
Oh
bit.
yeah, yeah. This function will do this whole traversing the tree multiple times. Actually, it's gonna be really fast because it's a hash map, but and it's a tree. Yeah, as far as I can tell, the hash map implementation of most languages is just a tree, a balanced tree, but it's a tree. Um, we're just gonna we're gonna do two things at once. We're gonna filter the real elements that we want, and we're gonna do the bit representation. Seems fine, I think.
Like architecture wise, we are probably doing a bunch of shit. Like we are not caring about separating concerns and doing one thing per function, but yes, we work.
We can do more separation concerns. Like for instance,
No,
we
no, no,
can.
I really don't want to do that now because that's the kind of algorithm that we can like do it, make it run, and then you can spend like hours and hours refactoring the thing.
Okay, so let me pick this. Are we gonna pick the elements before calling this function though?
What do you mean picking the element?
Yeah, because we need to have the unique elements. I'm suggesting. Do we gonna have like
Hmm?
this is already the A, B, C, D, and underscore, right?
Okay.
Okay, so let's do that. So it's gonna be a 4. I already forgot how to do 4. Oh, it's like this. Okay, so it's gonna be 4 element in. Okay, iterate. Okay, so it's gonna be 4 element in requested elements dot iter. Okay, so what we're gonna do? We're gonna try to find the bit representation of this thing. right? So let's try to find that. It's gonna be new bit. Actually, no, it's gonna be bit. I'm gonna call it a bit representation for now. Bit representation. So let's use the C example. What's C? C is CB plus false. Okay, so let's pick the bit representation of CB. I know it's in the map. So map entry, right? Map entry. Oh,
Hmm.
yeah, this can be really convoluted. So I'm gonna separate concerns here a little bit. Intermediate representation. We could do it in one line, but I don't want to do that. This will be a map entry of the element.
Okay, is that an option?
But I need to convert this U8 to a string again. I already forgot how to do that. Oh, it's like this. Okay. So what we are doing here, let me explain. This is CB. Okay? This is CB. Pick why? Because I'm picking the C, which is this. Okay? I'm picking the C, which is in the map, which is the element that I'm iterating, sorry. And I'm searching. Okay, what's the the hash the C? Oh, it's gonna be an option, and here's gonna be CB and a boolean. So we actually need to do like a bit. Can we do something like this?
To
Double bit
this.
pattern matching. Like I
Uh,
am already doing curry.
tuple, you mean?
Yeah.
Sure, we can.
Okay. Okay. So this is gonna be CB, and this is the false. But there's a problem. I need to find the representation of the intermediate representation, the bit representation, because I will concatenate its answer with bit. Seems fine.
Okay.
How are we going to do that? We're going to search in the map again, because I assure you that
But
this.
wait, isn't that an indeterminate, like, number of steps?
Um,
The amount of ways that you are following this stuff, you don't know it, the number for sure. So that's recursion, right?
how can I explain this? How can I explain
Okay, maybe you
this?
know it by the length of the. Uh,
Uh, wait. Um, I understood what you said. That is we don't know how many steps you're gonna go. We don't know. But what we do know, actually, this is a really good point that you made because I think we cannot do together these two things. I think we need to filter it later. I'm going to try to explain now why it doesn't matter how many iterations you're going to pass through. So
um,
let's try to keep up with me. This line right here, we are picking whatever the symbol that we have. We pick whatever the symbol that we have, and we are picking its intermediate representation and the bit. Okay. This intermediate representation, we need to find its bit representation, if that makes sense.
man, those names don't make sense at all.
Okay, they do make, but I will try to help you. So
Intermediate
element,
representation?
element,
Not really, man.
and then we have intermediate representation, which is the CB.
Like, that's the parent, right?
C.
That you want to follow and know the bit representation, should know it yours properly, right? That's not
Yes,
a Oh man.
it's because this does not make sense.
You can
Like
call
for
parent or something, like, makes more sense.
parent is better because you're thinking like a tree, right? Yeah, it makes sense. So the parent will be CB. Okay. Okay. But there's a problem. We need to find what's the result of CB as well. See?
Sure.
And
Then we can go on and on. right?
Then we can go on and on. That's exactly the
Isn't
thing.
that a recursive call?
It seems the way that we are portraying it seems like a recursion, but I didn't implement with recursion back then.
Oh, so let's take a look on the Python code.
Um. Okay, so are you watching my screen?
Yes.
This line, I am picking just the keys of the dictionary
Oh wait,
and
wait,
transforming to a list.
wait. Oh man, what is that?
What?
Look at 44, like line 44.
No,
Like
this is a
minus one.
yeah. This is the Python syntax for doing for doing a loop from n to 0 instead of 0 to n. You want to start from this guy.
Oh, okay, I see what you're doing. Okay, I see.
You want to go.
So
You want to
it's
decrement.
like okay, the starting, end, and like step, something like that, right? Okay.
Yes. Oh, this is crucial, man. I forgot about this. The way that you go through the loop matters.
Mm.
Yeah. Oh,
From the
now I see I
end
don't
to
use recursion. Because if we go from the beginning to the end to the beginning, I assure you that we already have this representation. We don't have to recursively find it. I'm going to repeat.
okay, okay, I
If
understood, I guess. You are beginning by the top, then you know the representation of the.
yes,
Do you?
yes, yes, look at this. If I start by this, every time this guy and this guy asks for it, we already know.
I want to see that on code. Like,
No, in the Python code is this line,
holy fuck.
but in because why? Because we are searching from the n minus one element. We are decrementing by one, and we want to do that until we reach minus one. Because this loops in Python is not inclusive. The last one. So this is zero actually.
Symbol
But
list.
this symbol list is our hash map. Just read this is a hash map. It's no problem.
Okay.
Hash map.
Okay, yeah, I can
We are,
see that. The thing is that the way we are accessing, like,
no, forget about the syntax, man. We are doing
I.
our represent
Okay,
our representation is
man,
better.
what is I in symbols list? Is that a number, like index, like as you are
Index.
sex an array?
Yes. It's exactly that, what you said.
So okay, yeah, that. Oh, okay, symbols list. Okay, I see, I see.
Okay, so what we need to do is the same damn thing. We just have to do. Oh, how you do this in Rust?
What exactly?
For loop, end to the
We
beginning.
have ranges.
Oh, you do have ranges.
Yes.
Okay, so this is gonna be for index in range. How is the syntax of range?
Yeah, it's like in Haskell, I guess. Like number dot number. And if you want inclusive, you put like an equal before the last number.
Oh, so the number on the right is not inclusive.
Unless you put equal in it.
Oh, but there is another problem. We need to pick the keys. So let items. So this will be map dot.
Wait, for some reason this is wrong. Wait, maybe it's parentheses? Oh no, let me search how to do it. Oh wait. Okay, that's right. Let me try the reverse.
Values. Okay, I want the keys of a hash map. Keys hash
Oh,
map.
that's easy.
Rust.
No, man, you just need to not to dot into it like keys, right?
No. But we need the items to iterate upon.
What do you mean? You
We
have
need to.
you have the hash map, and what you want is all the keys from it?
Yeah.
Man, it's probably just dot keys, right?
I don't think so.
Let's
Oh yeah, it
try.
is. Okay, you're right. Okay, so from we want to do instead of two, we want to do some like items.len.
Yeah, I'm not sure if you can put spaces.
Oh, that is ugly as hell then. Really don't like that.
Okay.
But okay.
I'm not even sure if this is doing
What is
the.
this number at the end? 1.
Well, it's a number.
It's what, sorry?
A number. Like the end.
Oh, the end. So we want
Yeah.
0.
Okay.
Okay.
By the way, that's inclusive, right?
That's inclusive. We want to count a 0.
Okay. Yeah,
Wait,
that is one thing that I'm not sure about. If we are doing the from z and z is greater than 0 until 0 by going like -1, -1, -1. I'm not sure if we are doing that. Like I would expect that, but let's try it.
it's gonna be really bad to discover that, man.
No, it will not.
Okay, so apparently it is inclusive, the right one. Okay. Okay, so the next step is, after having this loop, is to find the symbol in this correct position. So this will be like slat symbol. I don't know about the names for now, but items dot index. Okay. So it's still complaining about something that I don't know. Let's put type notations on these things because I'm lost. What is the type of keys?
Uh,
Holy! It's
yeah.
a fancy thing.
Oh
An
yeah.
iterator visiting all keys in arbitrary order. The iterator element type is arbitrary order. We don't want that.
Oh yeah.
We don't want arbitrary order because that will mess around with the property that to not use recursion. So get keys.
We probably want like all the entries and then sorting that if it's not sorted.
It's not a. I wouldn't call it sorting though.
Well, it's out of order and will be on order. It's literally sorting.
Yeah, that's true.
So take a look on dot entries or something. See if we have like both and if they will be on the order that we want. If not, we will be able to do it because we have, well, both.
Okay, so there's a function called insert a key only if it doesn't exist. Oh
No,
no, so
no, we want
entry,
to get
entry, and
entries.
entries in plural.
Yes.
Yeah, I don't think we have that, man.
Oh, so
But we could try.
yeah, let me try it here because I cannot see your stuff.
Yeah, no, I don't think we have entries, but you can try.
Capacity, clear, clone, drain. What the fuck is drain? Entry,
Oh no, capacity is not what we
expand,
want.
get. We have ether directly. That could be interesting.
Oh, we do have ether directly.
Yes.
Yeah, let's do a test drive then. I want to do a test drive. So
Okay.
let's do control comment. Let's call this whatever. Actually, I want to do it separately. And let's do
By the
4.
way, that's the first thing that we should have thought of.
Oh yeah, maybe, right? Um, what's the magic again? Magic hack to print everything? I always forget.
Not a hack, it's actually a really
Um,
nice implementation of macros.
Test. Okay. Let's try to print like this. So we need to call this function in here. So let's do encode. My LSP is gone for some reason.
Let's go only into like 9 and 20, man. I haven't ate it anything.
Oh, okay. So this is gonna be like this. And the map that we are passing will be test map. But I think we need some sort of reference in this guy. And mutable. Yeah. Okay, let's see if this compiles. Okay, it does not. Expected strut hash map found. Oh, it's because of type signature.
Mhm.
Let's return the map.
Oh, okay. Man, compiler errors can be quite nice sometimes.
Oh, but this will not work. Okay, so let's return a new one.
Hmm?
Let's return a new one.
Uh,
Return V. I don't know. It's gonna be a type signature of
you
this
could just,
type.
I mean, you could just delete that for now.
Oh yeah, no, but I don't want. Didn't want to mess around with the type, but you can remove it. Remove it.
Maybe we can comment that? Mm,
Not quite sure.
yeah,
Just
not
remove it.
sure how.
Okay. Cargo run.
Gotta go
Okay, it's
fast.
working. Okay.
Is
Yeah.
this
So
the order that you want?
no. Oh crap. It's not. It's not. Oh, you didn't know why? I know why.
Mm,
I do know why.
okay.
Because this is printing in the min heap order. But
Mm.
now we want the opposite of that. We want
Oh,
to go from the greatest to the
no,
lowest.
no, no, fuck, man. We can just invert that. Like either dot reverse. We can probably do something like dot ether dot reverse.
Okay, I'm trying. I added that to the code. Let's try to compile. And no, apparently it didn't.
Ah.
Ah!
Something. Wait. Method not found in SD collection. Ah. Oh, that's weird. Like those collections, they have ether one up. Ether? Why? Why is not only one ether type? That's. Oh no.
Oh, we do have one. It's just not reverse the name. Let me try again.
Ah, hell no.
Okay, definitely not.
How did you? Let me try to autocomplete here to see what I
Oh, feel
see.
free. Double-ended iterator is not satisfied. Whatever that means.
Well, in the worst case, I know something that we can do. Right.
Oh
We
man,
we
there's a
do
way
have.
to.
Are
Yes.
you talking about the next and checking if?
No,
Oh, okay.
actually. No, no, I don't know. I don't know, actually. I don't know. Wait, man. I think I said BS back there because this hash map does not have the property
Oh wait,
of.
let's clone that and then try to. We don't. Okay, so ether. Let me
Ether.
try to see if that's the case.
No, but I think it's just a coincidence, man. I think that the order is reversed, just a coincidence in this case. Because I don't know if the hash map has this property, you know? We need to
Hmm?
sort the map. Yeah. We kind of need to sort
Oh,
the
okay.
map.
Oh, okay. Yeah, we have the hash map and not the.
Yeah,
Oh.
this is not a tree. Although I think it would work because probably the hash map is implemented as a heap.
Hey, but yeah, I would not rely on implementations of the
Yeah, no,
hash map.
totally. I
So.
would totally not do that. How can we do that? Can we sort in a dictionary?
No, we transform that into something and then we sort this something.
Okay, so we're gonna have to do that, man, unfortunately.
Yeah.
That's sad. Okay, we didn't finish encoding today. That's so sad.
Yeah.
Oh, we basically did a recap and a
Okay,
function.
before finishing, can we recap? Well, you
Yeah, we
like
can.
go into the code. No,
Yeah.
but I would like to recap what we saw new in Rust.
Oh,
That's what
new.
yeah.
Okay, so new in Rust. Hey, I remember the borrow thing because apparently that's probably the highlight for me.
Okay.
That if we are trying to move something like in this piece of code, you need to use it before you are actually moving the thing because otherwise you're gonna have to do cloning
Oh,
stuff.
okay. Just one thing that maybe I didn't explain properly. If something it's doesn't have like a known size at compile time, it will not be on the stack. You know that already. It will be on the heap. and those usually don't implement the copy trait, so they don't clone by default. Like if you go to like let x equals y and y is on the heap, he will most likely not clone by default. So he
Mm.
would do a move because it's on the heap. So it's expensive, right? So you have to
Yeah,
opt in
that's
if you have to clone.
okay. That whole heap part, that's a little bit obscure to me still, because maybe because I'm not used to it.
Uh,
What
I
I did understand is
I
that we are doing some sort of moving references stuff, like pointers and stuff, and
okay,
we do
Lemos,
not have
Lemos.
access to it after doing this,
Lemos,
something
Lemos.
like that.
Maybe you don't know the name, but you already know the concept from C. Know
Yeah.
when you are using like malloc, you are like
Yes.
requesting memory. That's like
Yes.
those things are like from the heap, like that dynamic memory that you are requesting. Those are things that will be allocated on the heap. You have
Yeah.
the stack for things that has a known size at compile time, and the things that you don't know, they use malloc and they are allocated on the heap.
Wait, but when you're doing borrowing, you're actually putting things on the stack.
No, but uh, it depends. Not the object per se. You are only creating another reference, and that reference, that pointer, you could say, this is on the stack because the
Oh.
size of a pointer is known, right? What
Wait,
he's
wait, but
pointing to is on the heap.
wait, but now I'm confused. When you're doing moving instead of borrowing, how did how does the compiler knows that okay, I should remove this reference from the stack because
Uh,
this is being moved? How does it know this?
remove this reference from the stack.
Yeah, because as far as I understood, after these 4 lines of
It's
code, I
just that
could
you need
not do
to
this.
remove. Wait, wait, wait. Man, but what you asked, it's nice. Like, okay, new symbol, it's a pointer, right?
Yeah.
No, suppose that we are moving new symbol to symbol. New symbol is a pointer, right? How does it
Yes.
knows to get this like out of the stack?
Yeah.
First of all, it doesn't really need to. Like if so, for some reason he thinks he doesn't need to, he only needs for you not to be able to use it. So he enforces that by the rule that you saw. If he moves it, you cannot use it.
No,
But
no, no. But that's my question.
yeah.
What's the criteria that the compiler uses to know that after this is a moving? There's a
Oh,
criteria that
oh,
identify this is a
okay.
moving.
Oh, okay, okay, okay. That's quite good. Okay, so this here doesn't implement a trait called copy. The trait called copy, what he does is, if you are doing an assignment, it will be cloned. If you don't have it, it will be passing the thing. So it will be a move.
Oh, okay. Okay, so it does the criteria is assignment. So if I'm assigning something and this guy does not have the copy trait,
Yes.
then the assignment, if I have the trait, the assignment will be a clone. But if I don't, this is a reference.
Yes, and then he will say for you to not use the old one anymore, right?
Oh, I see.
Yeah, and that is also a funny thing. If I'm not mistaken, you can create like a struct and structs like if all the elements of a struct are known, the size at compile time, then the type of the struct, the size, it's known as compile time. This is like no brainer, right? But
Yes.
by default, I don't think it has copy. You have it to derive if you want to say like this.
Okay.
But you cannot derive, of course, if one of those like doesn't have the trait copy.
Okay, so you have to fight for it, huh?
Yeah,
Quite a different paradigm comparison to C.
yeah, but makes sense, right? Because they are
Ah,
expensive stuff. The thing on the
ah,
heap could be something expensive, so by default,
I
you
know, but
should not
there's a
clone it.
but that's the thing about low-level programming languages. The low-level programming language is less about safety and more about control. The developer knows what he's doing. That's the philosophy behind it.
No.
And
Yeah.
this is a really middle ground. Like we have the compiler constraining
Uh.
us and doing some sort of safe behavior, but we
Yeah.
still have some low level abstractions.
Yeah,
But
that's the intention of Rust. But
we
yeah.
kind of are like in a jail, right? We have like we have boundaries that we cannot like we have to fight for breaking this boundary.
Unless you use the unsafe keyword, then you can break bounds.
Oh, so you can't break the walls then.
Sure, like if you need to like manipulate a specific address in a low-level device, you can using an unsafe keyword, of course.
Oh, I see. Okay, 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 I'm interested.
Okay,
Interesting.
but you see about what is the borrow? Like if moving is given, borrowing is like okay, I will pass only a reference to it.
Yeah,
Like
I'm not passing you the entire thing,
yeah,
but I'm passing you a way to access it.
yes. And in this
Yeah.
case, it's an immutable reference, right? So it's totally fine because,
Oh,
well,
so the guys that are borrowing cannot change me.
no, like you can
Oh,
do
okay, makes sense,
whatever,
makes sense.
right?
Okay, because it's a borrowing procedure, like it has semantics in the name.
Yeah, and who of those two will free the thing?
I think the one that has the original.
Yes, because I'm just borrowing, right? I'm still the
Yeah,
owner, so I'm
I'm
the
not
one who will
responsible
free.
for it.
Yes.
Okay.
But you see why this would be illegal? We borrowing something to be inside the struct?
No, I don't.
Because the lifetime of those would be conflicted. So the new symbol would not be able to free because the heap node will still need it.
Oh, okay. 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 So
Because
this is why the one with the original needs to free it, right?
no. This is like here I can either clone it to be a new value to
Okay.
symbol, or I can move it. But why
Yes.
cannot I borrow to it? Because then, when I like theoretically, when new symbol goes out of scope because he's the owner, he will free. But heap
Yes.
node will like new node will not go out of scope, so we can still use it. But symbol will be freed. See,
Oh,
you
okay.
will have
So
a
if the
Dougling pointer. Like
okay, so if in your internal guts you have something from somebody else, and this other person, this other entity frees your thing, you have like a weird state where you have
yeah,
something, but inside you have something that does not exist anymore.
it's an unsafe state. It's a dangling pointer, I think they call.
I don't think
But
this
that's
is
not a
particular.
particular what?
I don't think this is particularly true in in this case. I think that the new node and the new symbol will die simultaneously.
No. We have no way to know those things, man. That's why it's not allowed. But that is one thing. I don't know about this yet, but I think you can do that by implementing some called lifetime. Like maybe you explicitly manage those stuff. But I haven't
Oh.
learned that yet.
Mm. Okay, so it's not allowed me to borrow in this particular scenario.
No, unless
How
you are
how is it no?
explicitly handling the lifetime.
Wait, for borrowing stuff, I need to know how long I'm going to use it for.
Yeah, for not do the situation, right? But I don't ask me much because I don't know about the lifetime
Oh,
stuff.
holy Jesus!
Man, like Rust will guarantee that you will not free two times, that you will not be without freeing, that
Yeah,
we will
but
not point to something that does not exist, that we will not like point to a thing thinking that is immutable but is mutable. He will guarantee all of those. But it's
okay,
just a
so
pain in the ass to a beat to those things.
okay, so basically the lessons learned is that if you try to make mutability safe, you need to take care of, with like need to take care about a bunch of different stuff.
That's not about mutability though.
No, it is because if
No.
you're using immutable stuff, nothing, all this conversation will be useless.
No, actually no. Like this situation that we just said here It happens even with immutability, of course. Because this is not about mutating, this is about, oh, okay, when I go out scope, I freeze something.
Oh yeah, you can just read it, right? I was thinking about writing the thing, and then you're gonna have like a panic attack. No, but you can also try to read it, but then you're gonna end up with the same problem. Yeah, it makes sense. Holy man, but this means that low level safe is paying a pain in the butt.
Yeah, that's a bunch of constraints, right? To a bit.
So you need to keep all of that in mind while you're programming.
Uh, oh yeah.
Like I need to think about the longevity of using something in order to borrow it.
Lemus, but there is no way we that don't know Rust probably properly and are not using much know about all this shit. Like thinking about all like in a with instinct, right? We can all just, oh, okay, the compiler is complaining, then I will fight him.
Well, yeah, but quite interesting paradigm. So low level making safe.
But see, like I guarantee, one allocation, one free, not less, not more.
Oh yeah, when you are removing control from the developer.
And something else. I'm not freeing if someone is already is still pointing to it.
Yeah, no, you're not seeing. You're not seeing. Okay, that's fine. But what? That's quite a.
That's
Like I
fucking
said,
awesome.
it's a different perspective. It's a different perspective, totally different perspective, because it's a mixed. It's a mixture between safety, or like some other language called soundness, but we are still trying to reach low-level abstractions with like references and stuff. Yeah, I'm interested. It sounded really complicated though. My impression is that okay, this is a pain in the butt to manage.
Oh yeah.
But that's fine, I guess. I think we can finish it here.
Yeah. So are you you end the string, right?
Yeah, I will do some offline work, I think,
Okay.
because this project is going